All right, so sometimes the camera cuts out on you. I'm sorry, but what we were saying towards the end of the last video is we're approaching summertime, and that means at this location where I'm at, with the sun over here, again, that's the sun. Where I was earlier was over here with this stack of books, and we said that was our spring equinox, and I had that over there. That says March, and I want you to associate the 21st of all of these months with that. So that is when we were entering spring, and during the 3 months between March over here, then April and May, and now we have our first day of summer. That is now June in the northern, well, it's June everywhere, but in the northern hemisphere, we say it is summertime because, again, those light rays are very, very direct, meaning perpendicular to the surface if you are in the northern hemisphere, perpendicular to where the location that those photons hit the surface. If I go down south, you see how that's a very sharp angle between the surface of the Earth and where the photons are banging into it. So those photons are very spread out. So the folks in the southern hemisphere just started their first day in winter, and the folks in the northern hemisphere just started their first day in summer. Okay, and another thing that's interesting to hopefully be able to see from this perspective is if you're hanging out on the North Pole up here, and you see where the line that is the boundary between day and night now no longer goes through the North Pole. It's on this side, kind of the far side, if you will, the dark side of the Earth relative to the sun. Since the sun's that way, this is the demarcation line between light and dark. So folks hanging out up here are going to get 24 hours of sunshine. It doesn't matter what time of day it is. As that Earth rotates, we're not in any sort of darkness until we get a certain latitude south of the North Pole. And again, remember we said the Earth is tilted 22.5 degrees. So since 90 is where Santa lives, we got to go 22.5 degrees south of Santa. And that is what, 67 and a half? 67 and a half degrees then. That is the Arctic Circle. That is this dotted line right here. So anybody north of that from this during this season is going to get 24 hours of sunshine all day for 3-ish months, okay? 24 hours a day. Now, it doesn't mean it's bright sunshine. A lot of times it'll look kind of like twilight for the most of the day, kind of a dusk dawn kind of thing. It looks almost twilightish, but for 3 months until our next solstice now, we're going to get 24 hours of darkness, or I'm sorry, of light. The folks down on the southern hemisphere now, if we could get on the far side of the Earth here and see what folks on the southern hemisphere can see. And that might be a better way to look at it because you can see Antarctica right there, and the Earth itself is blocking the light from the light bulb, which is the sunshine. So folks here on Antarctica are not going to get any sunshine whatsoever because the Earth itself is casting a shadow upon itself. So folks then south of the Antarctic Circle, which is 67.5 degrees south latitude, won't get any sunshine at all. And boy, that'll be awfully darn chilly. And that'll be true again for 3 months until we get to, as again, the Earth, we continue our journey through 1 year. And I'm going to go till I get about here-ish. And I want to make sure, oh gosh, got to make sure that axis still points in the correct orientation. Once we get there, you can see again that we're going to get back to being equal, aren't we? We're going to go back to saying, hey, what we have is 12 hours of light, 12 hours of dark. because what we have is, again, we're in line here. These folks are getting sunshine, staying on the sun till boom here. The line of demarcation between day and night does once again go through the North Pole and South Pole, really. So that particular time of year is when the Northern Hemisphere is leaving summer, and so it's starting the fall. And so in this particular orientation, what we have now is a vernal equinox, which occurs in the month of September. And again, it's relative to the folks in the North Pole. So we call, I'm sorry, the autumnal equinox. The autumnal equinox. We're starting autumn. So this is September, and all of these dates I want you to associate 21. So March, start of spring, 21. June, start of summer, 21st. September, start of fall, that equinox, 21st, okay? And hopefully this camera will keep being nice as I move it here. Sometimes when I move it, it doesn't like it. But can you tell the boundary? And I'll try to make it a little more obvious here. Whoop. The boundary between light and dark goes right through the North Pole and through the South Pole. And so what that leads to is 12 hours of light, 12 hours of dark. So again, the Southern Hemisphere is leaving summer, just has an equinox right there. So that is our autumnal equinox, okay? And again, we're going to keep rotating, and I'm going to have us all keep going for another 3 months in our journey around our happy sunshine. And hopefully the camera continues to play nice. Okay. All right. So here, where we're going to go is to this guy, boom, right here. Okay. Now, first of all, what I want you to realize is, well, you can tell from that view, that's pretty obvious. We're looking at Australia, aren't we? And this is the South Pole. You can hardly see any of the North Pole. The North Pole is pointing away from the sun. So since the North Pole is still pointing that direction, which what I ended up labeling way up here in the front of the classroom, that's the North Star, kids. So since the North Pole is pointing in the opposite direction of where the sun is, then the Southern Hemisphere is getting very direct sunshine. So that's summertime down there. It's wintertime up here. Folks in the Southern Hemisphere or south of the Arctic Circle will experience 24 hours of brightness, 24 hours of sunshine a day. Folks on the North Pole, if you can tell, maybe even from right there. See now the North Pole, the planet Earth is casting a shadow on itself. So the folks here won't get any sunshine at all. Oops, I know, I'm sorry, I'm not lined up quite perfectly. This should probably be a little higher. But once it is, whoop, then you can see that those guys are going to stay shaded. And so these folks will experience 24 hours of darkness for 3 months until we get over back to March. And again, as we approach March, it'll be 24 hours of darkness. The sun will never rise above the horizon, but it'll look kind of twilight-ish for a decent amount of time. So in this location here, the way I have it, that's going to be the first day of winter for the Northern Hemisphere, which means it's the first day of summer for the Southern Hemisphere, and this then is called a winter solstice. This boom right there, that's going to be December. We're going to have the longest number of hours per day of sunshine for the Southern Hemisphere. They're going to have a very long day. The northern hemisphere is going to have a very, very short day. It's certainly not going to be 12, somewhere along the line of 8-ish hours of sunshine in something like 16-ish hours of darkness. So it's a very, very short day, December 21st. And then after that, the days will start getting a little longer until we get to 12 hours there. Then they'll get even longer and longer and longer till we get to about 18 hours of sunshine. Where June is, and then they'll get shorter and shorter to 12, and then shorter and shorter here. So again, the amount of time that we spend in the sunshine is significant, but also the angle at which those sun's rays are hitting. Boy, you can tell from this view right here is pretty obvious that Australia is going to get hit with a lot of sunshine, very perpendicular to the surface. Folks up here in Asia, North America, are going to get hit with sunshine at a very shallow angle. And so that, if you were to count the number of photons banging into the planet during any given surface area, the fewer of those there are, the less intense the heat is. And that's what's responsible for seasons, all right? It's not distance from the sun. It is the tilt of the earth, okay? And sometimes they'll ask you, well, gosh, what if the earth were tilted less? What if it were only a 10-degree tilt? Would summers be hotter and winters be colder? Would summers be colder and winters be warmer? Would they be more extreme or less extreme? What if we were tilted 32 degrees instead of 22? Would it make it more intense fluctuations? And the greater the tilt, the more intense the fluctuations. The lesser the tilt, the less intense the difference between summertime and wintertime is. There'll still be daily fluctuations in temperatures, obviously, but seasonal would be less if the Earth were tilted less than 22. Seasonal differences would be greater if the Earth were tilted more than 22. So anywho, this orientation, I want you to remember, I'm going to use this these months, March, June, September, December, to show you how seasonal constellations would appear too. That's going to be our next kind of bridge to going through the stuff that you've really learned, I think, since elementary school. So up till now, hopefully it's not that big a deal, but please do remember that gyroscope effect, rotational inertia. Please remember that. That's what keeps the Earth in a stable rotational axis. And also, please remember the geometry of those photons, where if they start out not parallel, they're going to spread out to the point to where they don't bang into the planet Earth. But if they do start out parallel and head towards the planet Earth, then they'll bang into them. So every photon that hits the planet Earth is parallel to every other photon, and they are parallel to the straight line that connects those two. In the sky, we call it the ecliptic, but it's just connecting, drawing a straight line from the Earth to the sun, parallel to that. All right, cool. Then we're going to move on to, I guess, latitude and longitude in the sky, which I can do real quick. I mean, it's not that big a deal. You guys all know latitude and longitude here on planet Earth. I already told you in the last video where longitude starts. Longitude starts, because again, you got to start somewhere. Longitude-wise in the United Kingdom right there. That's the first longitude. We go 0 and we go up to 180 here and then back down to 0. So longitudes start at the prime meridian. You all also know latitudes start at the equator. That's 0 degrees. And as you go north, you're at, every 10, 15, 20. These are usually labeled every 10, maybe every 5 degrees. Remember the Tropic of Cancer, northern hemisphere, 22.5 degrees north. Tropic of Capricorn, southern hemisphere, 22.5 degrees south. They sometimes say positive 22.5, negative 22.5. The poles, the South Pole is negative 90 degrees latitude. The North Pole, where Santa lives, positive 90 degrees latitude. So please remember, latitudes are relative to the equator, which longitudes are relative to that prime meridian. And again, they just had to start somewhere. And the folks who started this happened to be in England, so they said, all right, we're more important than you. But anyway, remember that, because we'll have terms that are associated with latitude and longitude in the sky for stargazing to tell you locations of stars.